All right, class. 2.1, day 2, using deductive reasoning. So yesterday we talked about conjecture and inductive reasoning. Today we'll talk about deductive reasoning. So deductive reasoning is a process that uses facts, definitions, accepted properties, and the laws of logic to form a logical argument. That is deductive reasoning. A process that uses facts, definitions, accepted properties, and laws of logic to form a logical argument. And in comparison, from yesterday, inductive reasoning was coming up with a conjecture formed or based off of patterns. So inductive reasoning was conjecture based off of patterns. And conjecture is kind of like a guess, an educated guess. So an educated guess based off of patterns. So example number 1, we need to tell whether each argument uses inductive or deductive reasoning. So letter A, Heidi likes all vegetables. Peas are vegetables, so Heidi likes peas. We're told Heidi likes all vegetables. Fact. She has said that she likes all vegetables. Peas are vegetables. Fact. So if Heidi likes all vegetables and peas are vegetables, it makes sense logically that Heidi also likes peas. So that is deductive reasoning. Deductive reasoning. We're not looking at a pattern here. We're not making a guess. We're looking at the facts. Heidi does like all vegetables. Peas are vegetables. So Heidi likes peas. All right, letter B. Plants can grow to be healthy when given sunlight and water. Mark's plants receive sunlight and water each day. So Mark's plants will grow to be healthy. So pause and think about this one for a little bit. The important thing to note whenever you look at this is it says plants can grow to be healthy when given sunlight and water. So it's even saying in this statement that plants don't always grow to be healthy when given sunlight and water. So saying that Mark's plants receive sunlight and water each day is not guaranteeing that Mark's plants will grow to be healthy. It's just a common observation that plants grow given sunlight and water. Or maybe we see a pattern of plants growing because they have sunlight and water. But it's not a guarantee. So this is inductive because we're using the pattern of what we know about nature or what we see in nature to help us out with that. So that is inductive. So picking out the differences in deductive and inductive can kind of be difficult sometimes. Example A is probably the easiest form of deductive reasoning to point out. It's making this definite statement. Heidi likes all vegetables. Peas are vegetables. So Heidi likes peas. Whereas you can have some more difficult deductive or inductive things to point out. But the key thing is looking with deductive, you're looking for definite facts. Whereas inductive, there's room for error. All right, so then looking at C, the rain stopped and the sun came out. Next, a rainbow will appear. So pause and think about that for a minute. Would that be deductive or inductive reasoning? The rain has stopped, the sun came out. Next, a rainbow will appear. Is there always a rainbow after a rain, even if the sun comes out? There might be somewhere. Maybe you don't see it. Maybe there's just not. It's something you don't necessarily know. You don't always see a rainbow after a rain. Doesn't mean it's not there, doesn't mean it is. So this is actually going to be inductive. There's some room for error here. A rainbow may not always appear. Or a rainbow could appear while it's still raining. So there's some differences there. All right, letter D, example D. Jose puts $25 into savings each week for 10 weeks. Therefore, Jose has put $250 into saving during this period. All right, we know Jose put $25 into savings each week for 10 weeks. So let's do some math and figure out how much that would be. 25 times $25 times 10 weeks will give us $250. And therefore, it's saying, therefore, Jose has put $250 into savings during this period. Facts. If he put in 25 each week for 10 weeks, he has put in $250 for that period. That is deductive reasoning. Deductive. All right, on to the next one, letter E. Quadrilateral ABCD is a rectangle. All rectangles are parallelograms. So quadrilateral ABCD is a parallelogram. So think about that for a moment. Do you think it's deductive or inductive? Dealing with facts, or is there some room for error? Is it based off observations or facts? Okay, letter E is just like our example A, where Heidi liked all vegetables. We're told that quadrilateral ABCD is a rectangle. All rectangles are parallelograms. So quadrilateral ABCD is a parallelogram, and that is deductive. So anytime, so we see that ABCD is a rectangle. We know all rectangles are parallelograms, so ABCD is a parallelogram. Deductive. All right, letter F. If you pass Algebra 1 with a C minus, then you move on to geometry. Joe failed Algebra 1, so he is not in geometry. So let's look at the information they give us here. It says if you pass Algebra 1 with a C minus, then you move on to geometry. So it's saying you have to pass Algebra 1 with a C minus to move on to geometry. Joe failed Algebra 1, so he wouldn't be able to move on to geometry, so he is not in geometry. So this is deductive. And we're not talking about maybe Joe's parents complain enough and they get him into geometry. We're not talking about that situation. Of course, there's human error. But just this That is still the rule there. Pass Algebra 1 with that C- to move on to geometry. All right, G. Ken has eaten a peanut butter sandwich every day this week for lunch. Tomorrow, Ken is going to eat a peanut butter sandwich for lunch. So think about that for a moment. Deductive or inductive? Are we dealing with facts that we can conclude that last statement with? Or are we just looking at a pattern? That would be inductive. All right, so we see that Ken has eaten a peanut butter sandwich every day for a week. The pattern is, it looks like he likes to eat peanut butter sandwiches for lunch a lot. So a good inductive reasoning, good conjecture to make with that, is that he's going to eat a peanut butter sandwich again. But that's not a guarantee. Maybe he decides, I've had too many peanut butter sandwiches, I want a ham sandwich. So this is inductive reasoning. Inductive reasoning. And then letter H. All of Sarah's friends have cell phones. John has a cell phone, so he is Sarah's friend. So think about this one for a moment. Deductive or inductive? All of Sarah's friends have cell phones. John has a cell phone, so he is Sarah's friend. All right, this one starts off sounding a lot like letter A, like Heidi likes all vegetables. Peas are vegetables, so therefore Heidi likes peas. It sounds a lot like that. But if we look carefully at what is said, we can see that there's a skip in our logic here, a jump in our logic. It doesn't quite make sense. All of Sarah's friends have cell phones. So we know all of Sarah's friends have cell phones. Does that mean every person that has a cell phone is Sarah's friend? No. John does have a cell phone, but that doesn't mean he's Sarah's friend. We just know that all of Sarah's friends, whoever they are, they do have cell phones. So there's a little bit of a skip there. So you need to pay attention to what exactly it's saying, not just listening to the way it sounds, but does this actually make sense? So all of Sarah's friends have cell phones. John has a cell phone, so he is Sarah's friend. That is inductive. We're actually just looking at a pattern there rather than the facts. So it is inductive. All right, then these other types of examples. What, if anything, can we conclude? So we're going to figure out something that we can conclude from this statement. What can we tell from this statement? What do we know? What else do we know? So if a figure is a rhombus, then it is a parallelogram. DESK is a rhombus. So what can we conclude about DESK? That it is a parallelogram. So we can conclude it is a parallelogram. So we know if a figure is a rhombus, it's a parallelogram. We see DESK is a rhombus, so we know it is a parallelogram. That's what we conclude. All right, look at letter B. If x equals 12, then y equals 10. So we know anytime x equals 12, y will equal 10. It also tells us if z equals 4, then x equals 12. So anytime z equals 4, x will equal 12. And then here's the information that here's the fact that we know. We know z equals 4. So what happens if z equals 4? We know x equals 12. What happens if we know x equals 12? Y equals 10. So we know x equals 12 and y equals 10. And this kind of assumes also that we're combining both of these statements, that they're not just standalone and separate situations. If x equals 12, then y equals 10. Also, if z equals 4, then x equals 12. We're kind of assuming that here, but we would know x equals 12 and y equals 10. And the last example, I go to bed if I finish my homework. I fall asleep if I go to bed. I fell asleep last night. Can we conclude anything, or what can we conclude from this statement? I go to bed if I finish my homework. I fall asleep if I go to bed. I fell asleep last night. Pause and think about that for a minute. What, if anything, can we conclude from the statement? Okay, hopefully you've had a chance to think about it. We actually cannot conclude anything. So let's look at what we know. It says, I go to bed if I finish my homework. Okay, so we know for this person to go to bed, they have to finish their homework. Then it says, I fall asleep if I go to bed. So anytime they go to bed, they fall asleep. But then they said that they fell asleep last night. They actually didn't say that they fell asleep in bed, just that they fell asleep. So we actually can't conclude anything. Maybe they fell asleep at their desk trying to do their homework, and they never finished it. Maybe they fell asleep watching TV. We don't know. So we actually cannot conclude anything. All right, that is it for the 2.1 notes.